Okay, good morning, everybody. Welcome to day 10 of the Sound and Light Unit. Today, we're going to be specifically talking about the electromagnetic spectrum. Ooh, how did that happen? Oh, today your whole job is to go through the slides presentation. There's 4 or 5 videos linked, and watching those videos is going to be really helpful today. So please take the time to do that, and then you have an exit ticket at the end here due by 2:30. Looking at a quiz on Friday, so on day 12 quiz. Today, what you're going to be doing is you're going to be going over electromagnetic spectrum light. So, kind of what are all the different pieces, what makes up them, what are some properties of those different pieces, and then what are the differences? What makes a radio wave different than an X-ray, and those kinds of things. So when we talk about the electromagnetic spectrum, we're talking about everything that occurs from radio waves at the low energy, high wavelength or long wavelength end down here on the left, all the way to the really high energy, high frequency gamma rays on the right. And in between, there's a lot of different things. So there's all sorts of things. And as we go from left here with radio waves to right on with gamma rays, our frequency is getting higher as we go. So the frequency keeps on getting higher and higher and higher, and the wavelength gets smaller and smaller and smaller. That makes sense, right? Because all of these waves travel at that same speed of light, and wave speed, if that's constant, if we're changing frequency, then wavelength will also have to change because speed equals frequency times wavelength. All right, sorry, it skipped one. Let's start with radio waves when it pulls up here. Well, I guess while we're waiting for the radio wave slide to pull up, we can start with microwaves. Microwaves are, never mind. So radio waves are the longest, lowest energy on the electromagnetic spectrum. They're really, really big, long um, wavelengths, so they can be 1,000 meters, so a kilometer to 20 centimeters. So if we could somehow see radio waves, we would see these big, long wavelengths that are passing through the air and through lots of different things. So if you have a radio in your car, you have a radio at home, what they're actually doing is that antenna is looking for those big, long radio waves. And those radio waves then can carry information that your speakers can now interpret in sound. They're really low energy, so they're really not dangerous to us at all. And if you think about, let's say you're in the car, there's the AM and the FM dial, right? You can listen to AM radio or you can listen to FM radio. Radio is a little bit weaker of a sound, right? It sounds a little bit more fuzzy. It's not as strong. It's not as clear. But AM radios, because they're longer, can travel longer distances. The shorter the wave length, the higher the frequency, the less space that they can travel and carry information. So, really long radio waves can carry information a really, really long way. And that's why AM radio works pretty much everywhere and FM has a shorter range, but it sounds better because it's more powerful. Microwaves are actually obviously in microwaves, right? That's why the appliance is called a microwave, but they're also used in cell phones. Cell phones use microwaves to communicate, so your cell phone's emitting microwaves. Um, a lot of satellite, not satellite, satellite communication actually uses microwaves as well. And we're looking anywhere within that kind of on the really long end, kind of on that fringe of the radio wave spectrum of 1 meter long to 1 millimeter long. So there's 1,000 different wavelengths a microwave could really be if you go by millimeter increments. But there's just lots of microwaves. They do a really nice job because they actually do a good job of vibrating water, and that's what makes a microwave oven work. So they heat up water really easily, and that's why foods with lots of water in them heat up really quickly in the microwave. Um, and then if you guys hear about 5G now in the news, 5G is the new cell service. It's a shorter wavelength, so they have to have more towers, but it's a stronger signal. So it's a stronger wavelength, more energy, and so it carries a faster signal and it carries information faster. And that's kind of what's the cool thing about it. So again, YouTube video, click on it, watch it. Our next type of wave, if it loads. Our next type of wave is infrared. So infrared is a lot of people associate this with heat. So if you go through the lunch line at school, they have those kind of big heaters that put off that kind of orangish reddish light. Those are often infrared heaters. They produce a lot of they can warm things up. So they're used for things like that. TVs and stereo remotes. So if you have a the remote for your TV, they use infrared, so it's a low energy wavelength. It's a little bit smaller than microwaves, and it can transmit energy and information really pretty quickly for what we use it for. So that's why when you turn on your TV, when you press the power button, the TV turns on because that signal goes from the remote to the TV. Um, and then if you're kind of into the military stuff, guided missiles use infrared. They a lot of the time, so they can mark something with an infrared light that human eyes can't see, but they have equipment that will pick it up. And then night vision goggles also use infrared a lot of the time. So you can see here, this picture down here, the cat. Those are the areas where there's more heat, more infrared heat being emitted on the guy. Obviously, his skin is the warmest, his shirt and all the different things underneath it um, are his skin is the warmest, so his shirt seems a little bit cooler and looks like he's got some sort of glove on, and that gets cooler and cooler as we go. Then our fourth type of electromagnetic radiation is visible light, and this is what our eyes actually can pick up. So these are everything from red, orange, yellow, blue, green, indigo, violet. These are the colors that you and I can see. There's a lot of great things. We're going to spend a whole day or two on color, but check out this video. Um, our eyes can pick up wavelengths between that 700 and 400 nanometer range, and that's the spectrum we call visible light. Red being the longest wavelength, the lowest energy, is on the 700 nanometer side. That violet is on the 400 nanometer side. So the violet has a shorter wavelength, a higher frequency, and then carries more energy. It's kind of why if you look at like a candle or any type of fire, the blue flames are hotter, and that's kind of the idea is that that energy that's being emitted from the blue flame, it's just a higher energy, and that's why it appears to be blue. If you're kind of special, I can see. We did a test while I was in college that I can see about 390 nanometers, so I can see slightly into the ultraviolet spectrum, but I can't see all the way to the end of the red spectrum. So my eyes aren't quite adapted to that exact 700 400 range, but I still have some a normal vision. Some people can see a little bit longer into the infrared. I can see a little bit shorter into the ultraviolet. Things like frogs and snakes are on, oddly enough, on that. So I think snakes or frogs can see infrared. or some species of frogs, and then there's some species of snakes and some species of spiders that actually see into the ultraviolet. Come on, go to the next slide. All right, after visible light, we're moving on to the stuff that actually can harm us. So this stuff has enough energy that it's going to be dangerous to human beings and other living things because it's got enough energy to break those bonds within atoms. So this is going to start to be a little bit more dangerous as we go. And obviously, as we start, the next section is ultraviolet. We kind of break it into three categories of UVA, UVB, and UVC. Um, but ultraviolet light is what causes sunburn and then can actually cause skin cancer. So that's ultraviolet B. So ultraviolet light is what they use in black lights. Some remotes, if you have a Samsung camera on your like a Samsung phone, you can actually pick up ultraviolet lights from remote controls if they use ultraviolet, because some of them do. So they're used in black lights. They're used to kill germs. Our goggles containers in our classrooms use ultraviolet light to kill bacteria on the goggles. So every time you get a sterilized, clean pair of goggles, the fluorescent lights in the school, those are get into the ultraviolet spectrum. Laser engravers, and then obviously skin cancer is something that results of ultraviolet. It's also what gives you the sunburn. And if you get a sunburn, it's not a terrible thing. Obviously, it's uncomfortable, but repeated exposure and really repeated damage, because that's what it is. It's damage. You're killing your cells, is going to make you more likely to develop skin cancer. And obviously, it's not a guarantee. And even if you don't burn, you're not at risk for skin cancer. Doesn't matter the pigment of your skin, you're still at risk. So it's an important thing to wear sunscreen and sun protection and be cautious about certain things like that. But there's a lot of things that go into this ultraviolet range that we still actually use for a lot of cool things. Obviously, we use them to disinfect things in school. They're relatively safe. We can kind of control them. They're not going to go through uh, very thick objects. I mean, you can wear a T-shirt and it's going to stop ultraviolet rays. So check out this YouTube video, watch it. It's going to be another great resource. Again, we have a test on Friday, so in 2 days. All right, moving on then from ultraviolet, we're getting a little bit stronger, a little bit more dangerous, and at this point, the wavelengths are getting shorter. The frequencies are still getting higher. All right, come on. All right, the next type is the X-ray, which I think all of us are relatively familiar with. You probably had an X-ray at some point in your life. Um, so, what are X-rays? They're really high energy photons. Now we're going to start thinking about them as photons because they act more like a particle than a wave. They're really, really short wavelengths, high energy, high frequency. And X-rays will actually pass through soft tissue. They'll pass through your skin without being absorbed, and the only thing that's going to be it's going to absorb it are hard things inside of your body, like bones and structures. So that's why if you get an X-ray, right, you can see your bones, is because they put a film that picks up X-rays underneath your hand or whatever. In this case, this is the hand, and then they shoot X-rays at it, and um, wherever those X-rays don't make it through stays white, and that's why we see the image of our bones. So obviously, X-rays are great for medical technology. We use them all the time to diagnose things like broken bones, structural problems. There's some scanning and MRI type imaging that we use, X-rays in multiple dimensions. So it's cool, and we can create kind of 3D pictures. But we also, if you hear about somebody doing radiation therapy for cancer, a lot of the time they use X-rays to try and kill those cells. And you might be thinking, well, if these are dangerous and these things cause cancer, because they do. If you're overexposure to X-rays will cause cancer. It killed one of the more famous scientists of the 20th century, and Rosalind Franklin, who was instrumental into discovering DNA, or the structure of DNA. But they use it because they will kill cancer cells. Cancer cells are notorious for being very, very difficult to kill. And that's why we use such harsh treatments, is we really want to make sure we kill those cells. And it's part of the reason cancer treatment and cancer is such a difficult disease to deal with, is because it takes a huge toll on your body, because not only when you're going through radiation therapy are you killing the cancer cells, you're also killing a lot of the healthy cells around it. And this is, one of the reasons that cancer patients often lose weight, appear weak, or are weak, is because their bodies are really fighting just to stay alive from the treatment, along with the cancer that's taking all of that nutrient and all of the resources away from the rest of their body. One more. Gamma rays are really, really small. They're into the picometers. It's just a ridiculously small unit. And gamma rays are super high energy. These are really dangerous for living things. So what do we use them for? We use them to actually kill and sterilize medical equipment. So if you become a nurse, or a doctor, or kind of anything in that area, and you work in an operating room, they'll use gamma ray radiation to actually disinfect a lot of their medical equipment, make sure that there are no bacteria, so that's sterile. So when they'll scrub and wash their tools, and then they'll use gamma rays to kill all of the bacteria and things like that on them. So they know when they, go to operate on their next patient, that they have clean tools and they're not going to infect anybody. Radiation therapy and nuclear medicine to fight cancer, it's kind of the same thing. This is really, really aggressive uh, cancer treatment. This is going to be really tough on a cancer patient, but it's also going to really fight that cancer hard. It's going to do a really a really good job of killing those cells, those cancer cells that we want to get rid of. But it's also very difficult for our bodies to handle. And part of the reason that cancer treatments are so tough on the human body. All right. So your job today is to complete this exit ticket. So list the types of electromagnetic radiation, right? That whole spectrum from shortest wavelength to long wavelength, and then give uh, one example of a use from each type. So give me a radio wave, give me a gamma ray, everything in between. What do we use those things for? All right. If you have any questions, please reach out. Make sure you sign up for your individual one-on-one meeting. It's only 5 minutes. I think if you talk to the people that did it yesterday, it's fairly harmless. It's pretty easy. It's pretty quick. I just want to know how you're doing and if I can help you. All right. Have a fantastic day, everybody else. Talk to you tomorrow.